Yeah, so today we're going to be looking at rational functions and polynomial division. Just a few things we need to know before we get into the idea of partial fractions and partial fraction decomposition. So let's start off with the idea of a rational function. So a rational function r of x is equal to some polynomial p of x divided by some polynomial q of x. Okay, so this is what we call a rational function. For example, we can have the numerator being a quadratic function. So let's say 1 plus x plus 2x squared. And then the denominator can be something like a cubic function, x plus 3x cubed, for example. Okay, this is a rational function. Now, this degree of the numerator is given by the highest exponent in that polynomial. So here, the degree of p is 2. Okay, because it's a quadratic polynomial at the top. And then at the bottom, we say that the degree of the denominator is 3, because that's the largest exponent in the denominator's polynomial. So here, the degree of q is 3. Okay, so you can come up with any polynomial for the numerator, any polynomial for the denominator, and you got yourself a rational function. Now, when we go through the partial fraction decomposition, there's an important step we need to do before we get onto that decomposition part. And that step is making sure that the degree of the numerator is less than the degree of the denominator. Much like how if you have just a rational number, for example, r is equal to 10 over 30, for example, we can divide these to get something smaller. So we can divide the top and bottom by 10, and we get 1 over 3, for example. Okay, so in a similar way, we can divide the top polynomial by the bottom polynomial, and we will get some fraction as a remainder. Okay, and that's the important part that we need to find. Okay, so we're going to take the top polynomial, divide by the bottom. We're going to get some polynomial plus a fraction, which will be some smaller polynomial at the top and a larger polynomial at the bottom. Okay, so let's have a look at an example. So example 1, we have x cubed plus x divided by x minus 1. So here we see the degree of the numerator is 3, the degree of the denominator is 1, which means we can actually simplify this into some polynomial plus a remainder rational function. Okay, because the numerator has a higher degree than the denominator, we can divide them. So the way that we divide them is using polynomial long division. So it's very similar to numeric long division that you learned, but here we don't have numbers, we have the terms of the polynomials. So we're having x cubed plus, now there's no x squared term, so we're going to leave that blank, so we can put a 0 for that. And then an x term, we've got that. And then there's no constant term, so we can either leave that blank or we can put a 0 there. Okay, so we've got that polynomial. Now we need to divide this by x minus 1. So we write x minus 1. Okay, in the same sort of format that you would have done using long division with numbers. Okay, so we go term by term and perform the division. So first, how many x terms go into x cubed? Or another way of saying that is x cubed divided by x minus 1. If we do that, we're going to get an x squared, and we're going to have some bits left over. How do we find that? We take our x squared term, we multiply it down, and we end up with x cubed minus x squared. Okay, that's just multiplying it down. Okay, exactly the same as you would have done with the numbers. Then we subtract. So x cubed minus x cubed, that's going to be 0. 0 minus x squared, that's going to be x squared. And we can take down the x. And then we go again. So x squared plus x, we're now dividing that by x minus 1. We're going to be left with an x. Okay, x squared divided by x, that's x left over. Then we multiply. So x times x minus 1, that's going to be x squared minus x. Then we subtract them, and we're going to have x squared minus x squared, that's 0. X minus x, that's x plus x, that's going to be 2x. Okay, and we can carry down the 0, but we don't need to do that. Finally, 2x divided by x minus 1, that's going to be a 2. 2 times x minus 1, that's going to be 2x minus 1. And if you want to take down the 0, you can do that. Then we need to subtract them. So 2x minus 2x, that's 0. 0 minus 1, that's 1. And then we can stop there because we can't go 1 divided by x minus 1. This is the remainder. Okay, so we can't do the division anymore. So we stop and we say that is our remainder. So we can write this as x cubed plus x divided by x minus 1 is equal to, we have the whole number part, if you want to think of it like that, is going to be x squared plus x plus 2. And then we have the fractional part, if you want to think of it like that, which is plus 1, the remainder, divided by x minus 1. So this part here, this is like the whole number part. If you were doing this with numbers, then you would say that is the whole number part. And then this leftover part, this is the remainder or the fractional part. And we can see now with this fractional part that the degree of the numerator is now less than the degree of the denominator. So the degree of the numerator, you can call that 0. The degree of the denominator is 1. So we have that 0 is less than 1. So that's fully reduced now. That's as small as we're going to get it. Okay. So this is the whole idea of polynomial division. We take some complicated rational function where the numerator has higher degree than the denominator. That allows us to divide the polynomials into a whole polynomial part. So we've got this quadratic part plus the leftover part or the remaining rational function part. Okay, or the remainder after division. Okay, let's take a look at another example. So example number 2, we have x cubed plus 4x, and we want to divide this by 2x squared minus x plus 4. Okay, so the degree of the numerator is 3 because it's a cubic. The degree of the denominator is 2 because it's a quadratic, which means we can divide them. Okay, to get a whole polynomial part plus a fractional part. Okay, that's what we're trying to find. So let's set this up. Okay, we've got the part we're trying to divide here. So the x cubed, we don't have an x squared term. We do have a first order term, and then we don't have any constants, so plus 0. Okay, and we're trying to divide this by 2x squared minus x plus 4. Okay, so let's do the division. X cubed divided by 2x squared, that's going to be 1/2 x. Okay, we're not worried about the lower order terms. That will come later as we do the division. We're only interested in this x cubed part. That's the largest. Okay, then we multiply through. So we're going to end up with x cubed minus 1/2 x squared plus 2x. And then that's, yeah. Okay, then we subtract. And then you can take down the 0. We're not too worried about that there. Okay, so then this will come down afterwards, but it's 0, so you don't need to. Okay, let's do the subtraction. X cubed minus x cubed, that's going to be 0. 0 minus 1/2 x squared, that's 1/2 x squared. 4x minus 2x, that's just going to be 2x. And then, of course, the 0 is there, but you don't need to worry. Okay, next, we're going to take this 1/2 x squared plus 2x and divide it by 2x squared minus x plus 4. So 1/2 divided by 2, that's going to be 1/4. So we have 1/4 there. And then the x squared and the x squared, they cancel, so we're not worried about that. Then we multiply across. So 1/4 times 2x squared, that's going to be 1/2 x squared. 1/4 times minus x is minus 1/4 x. And then 1/4 times 4, that's just 1. And then we need to subtract. Okay, so 1/2 x squared minus 1/2 x squared, that's going to be 0. 2 minus 1/4, that's going to be 2 plus 1/4. That's going to be 9/4 x, and then 0 minus 1, that's just minus 1. Okay, now we see that we're left with x divided by 2x squared minus x plus 4, but already the degree of the numerator in that case would be less than the degree of the denominator. So we stop here and we call this the remainder part. Okay, so we've got the whole polynomial part, and then we've got the remainder part left over. Okay, so let's put all of this together. We're going to have x cubed plus 4x divided by 2x squared minus x plus 4 minus x plus 4, yep. And that's equal to the whole polynomial part, again, if you want to think of it like that, is going to be 1/2 x plus 1/4. So that's the whole part. And then we have this remainder that's left over. That's 9/4 x minus 1. And that's still divided by 2x squared minus x plus 4. Okay, now we can't divide that anymore because the numerator has degree 1, okay, because it's x to the 1. The denominator has degree 2 because it's x squared. So we stop there. There's no point in continuing that division there. Okay, so again, this we can think of as the whole polynomial part, like the whole number part. And this over here, this is the remainder or the fractional part. Okay, so again, the whole idea is to take this complicated rational function that has a higher degree numerator than the denominator and try and simplify it by doing the division. So we have the whole polynomial part, which is a lot simpler, and then the leftover fractional part that we're going to have to deal with. Okay, so why do we go through all of the trouble of splitting up the rational function like this? Well, the reason is that we're going to be looking at integrating these rational functions. So if we take a look at this example here, the integral of x cubed plus x over x minus 1 dx. We're trying to integrate this. Integrating this directly is really difficult. Okay, so you can try a U substitution, maybe a trig substitution. It's quite difficult as is. However, if we first do the division and simplify this, then you'll see it's much easier to integrate. So if we go back to what we had here, back at example number 1, we see that after doing this division, we get x squared plus x plus 2, and then the remainder part. So we can actually write this as x squared plus x plus 2 plus 1 over x minus 1. Okay, so you see we wrote it out in its expanded form with the whole part and the fractional part. Okay, so these are equivalent, but look how much easier this is to integrate. The first part is just a polynomial. That's very easy. So integral of x squared, that's going to be 1/3 x cubed. And then we're going to have plus 1/2 x squared plus 2x. And then even this fractional part is also easy to integrate. It's going to be the natural log of x minus 1. And don't forget your plus c. So you see, before we did the division, this was pretty difficult, or it looks quite difficult. And then after we did the division, we found that it's actually not so bad. Yeah, you get your polynomial part, that's easy. Your fractional part, that's pretty easy as well. Okay, so that's the whole idea of doing this polynomial division before you get to the integration. Okay, so now the problems we're going to get to in the next lecture aren't going to be as easy as this. There's going to be an intermediate step called partial fraction decomposition. Okay, it sounds like a mouthful, but it's really not so bad. The whole idea of that is that if we have something like the integral of 1 over x plus 2, x minus 1, for example. Okay, so if we expand that out, again, we get a rational function because the degree of the numerator is 0. It's just a constant. The degree of the denominator is 2. Okay, because if you expand that out, we get a quadratic. So we can't divide this anymore, but it's still pretty difficult to integrate. Okay, so this is after we do the division, for example. Now, there's this theorem that says that if we have something like this, where we've got the product of two terms in the denominator, this nice theorem says that we can rewrite this as some constant a over x plus 2 plus some constant b over x minus 1, okay, where we need to find what a and b are. Okay, so that's what we're going to be looking at on Friday. Okay, so this is the idea of partial fraction decomposition. So after you do your long division, you might end up with something like this. We can further simplify by splitting this fraction up into two fractions. And then, of course, each one here can then be integrated separately. Okay, so this is called the partial fraction decomposition. Okay, so on Friday, we will go through how do we split up these fractions, what are the rules involved, and also how do we find this a and b. Okay, once we can find a and b, integrating is very easy. Okay, so again, that's the plan for Friday. Remember, on Thursday, you're going to be writing your quiz during the lecture period. Okay, so that 1 hour period, that's for the quiz. Remember, it is a summative quiz, so you are going to have to write out your work, scan it, and submit it. Okay, so only 3 questions, 5 marks each, so it shouldn't take you too long. but you do have the full 1 hour to complete it. So please go through your work, check your answers again, and then submit it. Okay, so that's for Thursday, and then Friday, we'll go through this partial fraction decomposition and look at a bunch of examples. Okay, but if you have any questions in the meantime, please just email me or post your questions on the WhatsApp group. Remember, we also have the tutors that can help as well. Okay, but until then, please go through those homework problems and the mixed integral problems. Okay, so I'm going to be choosing questions from that for your upcoming test and the supplementary test as well. Okay, so those questions will be from that list of integrals. Okay, so I'll see you next time.